You are welcome to this class. In this class, we're going to look at quantities and units. We are going to define them, look at types of quantities, types of units, and everything you need to know in physics when it comes to quantities and units. The first thing we need to do now is to define quantity. So what is a quantity? A quantity, in a simple terms, refers to property. That is property that can be measured or quantified. If you can measure it or quantify it, such is called what? Quantity. When we say measure, this is a pen, for instance. You can measure the length. Okay? So length is a quantity. This is, say, cup. There is water inside. You can measure it. So volume is quantity. So any property you can measure or quantify, such is called what? Quantity. So the value you will assign to this, assume you assign 20 something. I don't want to put the unit yet. I don't want to put the unit. Or this is a wood, and you measure the wood. You know the length of the wood. You put a value, number. So the number you assign to each of these features, volume, length, these are called what? Quantities. Okay? So now, let's look at general examples of quantity. Examples. Examples are length. For instance, length of a rod. Mass. The mass of textbook. How heavy it is. You talk about time. These are quantities. The time it will take sunlight to reach the earth. From the sun to the earth. The time it will take it to reach. Time is a quantity. Talking about, say, electric current. Electric current is also what? A quantity. Say, the current from battery. Okay? Temperature. Temperature is also quantity. For instance, the temperature of boiling water. You have water you are boiling. The temperature of the boiling water. So temperature is quantity. Say velocity or speed. Say speed. The speed of a car. That is a quantity. Say volume, as I said earlier. The volume of a can of water. All this you are seeing here are examples of quantities because we can assign numbers to them. Numbers. 20 meter, 50 kg, 2 seconds. Electric current, 20 amps. Temperature, 10 Kelvin or 10 degrees Celsius. Speed, 10 meter per second. Volume, say 5 meter cube. All these can be measured. All these can be measured. Because you can measure them, we say what? They are quantity. We have types of quantity. Say types of quantities. We have types of quantities. There are two. We have the scalar and the vector quantity. We are just introducing this, okay? When it comes to scalar, we are talking about values only. Values. Say, for instance, a cup of water. What is the volume? The mass of something. The time. Speed. Just only values. No direction. When it comes to vector quantities, vector, they have both numbers and direction. That is, they have both magnitude and direction. For this is only magnitude. Why this? This with both magnitude and direction. Okay? Both magnitude and direction. Let me give you an instance. Say we have here Alice, and we also have Bob. Okay? Alice is telling Bob, meet me at the park in 30 minutes time. As you can see, this 30 minutes is just a value. This 30 minutes has no direction. This 30 minutes is called what? A scalar quantity. This is just 30 minutes. We are using it to describe time. How many minutes time should Bob meet Alice? 30 minutes time. There is no direction. Therefore, we say this is what? A scalar quantity. What is this? Time. The time that this one is describing, this quantity, is a scalar quantity. But let's put some flavor. Say again, why Bob is trying to leave the house. Alice sent a text message to Bob. He's telling Bob, I am 10 minutes away, walking northwards the park entrance. Alice sent a message to Bob, telling Bob that I am now 10 minutes away, walking north towards the park entrance. This information now is bringing in both the time and also include the direction. So this one that is describing direction, not only distance. Because if this is a building or this is a park, for instance, assume this is a park, okay? Say Alice was here, for instance. Alice told Bob, meet me in 30 minutes time in the park. 30 minutes, there was no direction because time cannot carry direction. All of a sudden, Bob received a text message saying, I am 10 minutes away, walking north towards the park entrance. As you can see, this new message contains direction. So, the distance is walking now contains direction. Because it contains direction, we say such a quantity is what? Is a vector quantity. Not just value, also contains direction. Okay? So, as I've said, when you look at scalar quantities, we have temperature. It's an example because this one will only give you, say for instance, 20 degrees Celsius. There is no direction in this description. Say mass. Mass will only tell you 5 kg. No direction in this information. Time. Time will just tell you 10 seconds. It will not give you direction. Even speed. Speed will just tell you 60 kilometers per hour. It will not give you direction. So all these guys, these quantities that are not giving us direction, they are called what? Scalar quantities. But when it comes to vector quantities, we have, say, velocity. This velocity, I can say 60 kilometers per hour eastward. That means I'm going towards the east. This is speed. Only contain how fast you were going. But this contain both how fast I'm going and also the direction. So velocity is an example of what? Vector quantity. You talk about force. Force contain both values, say 20 Newton. We are going to look at all this in this channel. Force, 10 Newton downward. Say, for instance, the force of gravity that is pulling you down. 10 Newton downward is giving the value, is giving the direction of the force. Okay? Displacement. Displacement is like distance. For distance, we put it under scalar. Because we can say 10 meter. Okay? We can also put this as 10 meter, but we must put the direction. 10 meter north, for instance. 10 meter south. So distance is scalar, while displacement is a friend of distance in the world of vector. When you are ready to put direction into distance, you are talking about displacement. So when you go further, that is why when we are describing velocity, we say is displacement over time. Because this velocity has direction. Who is bringing the direction? It is the displacement. While speed is talking about distance over time. This one has no direction, so it only carries this quantity that has no direction. Also, we have here acceleration. Acceleration is derived from velocity. Say you have 9.8 meters square downward. This is what? Acceleration due to gravity value. So this, that is value. Magnitude is value. And also direction, going down, downward. Aside this, because the information we bring in here now was about value and direction. Now I want to talk about another type of quantity. Quantity. Say quantities. We have another classification. We actually classify them in terms of direction, in terms of magnitude. But now I want to use another way of classifying quantities. We have what we call the fundamental quantities, which we also call the basic quantity. Then we have the derived. This is fundamental or basic quantities. This is what? Derived quantity. So what are fundamental quantity? Fundamental quantity are the base quantity, as you can see. Base quantity. They are set of quantity in a system of measurement that are defined independently. Their definitions are independent. They don't depend on anything. Actually, they are the foundation of quantities. All these quantity, derived quantity, are derived from these base quantities. That is the fundamental quantities. Okay? So we have two types of quantities again. The fundamental quantities and the what? And the derived quantities. You should know the difference. We are going to look at all of them. Before we continue here, that is this fundamental quantity and derived quantities, there is need for us to understand what is called the SI unit. SI unit. The SI unit, which you can also call the International System of Unit, that is International System of Units. That is SI unit. When we say International System of Unit, that is SI unit, there are units that are internationally accepted by scientists. Okay? You agree with me? You might have a different unit in your country for distance or in your language. Another kind of way of giving unit to time in your country, for instance. But when it comes to science, globally, worldwide, there is a standard we must use to represent distance. And there is a standard we must use to represent time. It's like, for instance, you have this country now. I'm just drawing anyhow map. So this is India, okay? For instance, I might decide to call it cuckoo. Another person say dada. Another person say vava. These are nonsense. We have a general name we use for this location. And that name is what? India. Generally acceptable name. The same thing with distance. When it comes to a space between 2 points, that is distance, the standard of measurement that is generally acceptable is what we are talking about here, other SI unit, International System of Units. Okay? So every quantity, remember we say quantity, we are talking about time, length, speed, mass, temperature. Every unit has more than one unit of measurement. Okay? We are talking about, say, 20 these seconds, for instance. Seconds. This is a unit we are using for time now, right? Say 10 meter, 10 meter. This is the unit we are using for distance or length. So this is what we are talking about. This is where we are now. Order this unit of a thing I'm talking about, okay? So this unit, they must be universally acceptable, okay? So what I'm saying is that every unit generally has more than one unit of measurement. For each quantity, there are smaller units. However, for uniformity, the International System of Measurement called the SI unit, that is what? The System International, that is System International. Generally agreed are what? And accept a standard for measuring quantities. Okay? For measuring quantities. They have a standard for that. Put that at the back of your mind. So when you want to become a scientist, or if you're a scientist, you want to measure time, for instance, say 10, you put something we don't understand. Say 10 bubu. What is bubu? This is not generally acceptable. What we know for time are seconds. We also know minutes. We also know hour. The same thing with distance, 2 meters. This is what we agree. If you bring another name, we may not understand what you are talking about. But when you say 2 meters, when I hear the word meter, I know the quantity you are referring to. You are talking about what? Length or distance. So now that you understand the meaning of SI unit, we cannot come back to this place. That is this classification that says fundamental quantity or basic quantity and derived quantities. Let's come back here now. So now, under these fundamental quantities, that is the basic quantity, they are the foundation of quantities. Generally, SI agreed on 7. There are 7 in number. This 7 cannot change. It's a standard. So put it at the back of your mind that under the basic quantity, that is the fundamental quantity, that is the foundation of quantities, there are 7 in number. 1 is length. Okay? The measurement of what? Distance. That is, we are talking about quantity now. Okay? 2, mass. 3, time. Remember, mass is the measurement of amount of matter. Amount of matter. Matter in an object. Time is the measurement of duration of events. Okay? 4, we are talking about electric current. Okay? The measurement of flowing of electric charge. 5, talking about temperature. The measurement of what? Thermodynamic temperature. 6, we are talking about amount of substance. Amount of substance. Okay? This is the measurement of quantity in terms of the number of particles or entity. That is, we are talking about atom or molecules you will find what? In a substance. Okay? 7 is luminous intensity. So, if you are asked in an exam, what are the fundamental quantities? These are the fundamental quantities. Length, mass, time, electric current, temperature, amount of substance, and luminous intensity. These quantities are the fundamental. Every other quantity, which are called the derived quantities, are coming from here. We get them from here. We are going to look at all that. So we are going to use this one to derive other quantity. So in physics, these are the generally acceptable 7 fundamental quantities. Aside this quantity, no more fundamental quantity. Okay? The reason why I explained to you earlier about SI unit is because they are the one, it's a body that defines this fundamental quantity. Now, let's go afresh now to start with the definition of what? Unit. Okay? A unit is a standard of measurement used to express physical quantity. If you want to express physical quantity, any physical quantity, we use unit as a standard of measurement. So, you want to define how much a quantity is, how big it is, how small it is, how large it is. You want to describe it with number. Okay? So, there is a unit to attach to it. For instance, 10 what? If I'm talking about time, 10 what? I should tell you 10 seconds or 10 minutes or 10 hours. With this unit now, you understand the quantity of time we are talking about. You agree with me that this quantity is less than this quantity, this is less than this quantity when it comes to seconds, minutes, and hour. So all these are the unit of measurement of time. Okay? Again, look at length. Say you want to measure the distance between this building and this building, or the length between them. If you just tell me 20, what 20? 20 what? You should tell me 20, for instance, meter, or 20 feet, or 20 kilometer. What is the distance between them? All these guys are units we use to measure length. Okay? So it gives us a way to compare, to comprehend. Because for instance, if I give you another 2 buildings on this other side, for instance, say the length between them is 5 meters. I say for this one is 20 meters. You can be able to understand what we are saying. But if I just say 20, I don't put meter, 25, how will you understand? You will understand. Okay? So, these units we are talking about are for what? They are for what? They are for quantities, right? They are for quantities. And we said that we have 2 types of quantities. That is, the fundamental or the base quantity and the derived quantity. So, I want to ask you, if you are asked now, what is the name of unit for this? You agree with me? Are fundamental units. The unit for this other guy is what? Derived unit. Okay? So, for this unit, we have 2 types. Okay? For the unit. We have the fundamental unit and the derived unit. Okay, unit. Here we have example like kilogram. That is for mass. Because mass is what? Is a fundamental quantity. So this unit is used for this mass. Okay? Seconds. Seconds is for time. So this seconds is unit for time. Ampere, which we call amp in short, is for what? Electric current. Okay? The Kelvin is for temperature. We also have mole. Mole is for amount of substance. That is for amount of substance. We also have candela. That is CD for luminous intensity. Meter. Meter, I also call it meter. It depends on the country you are or the English you are using, either UK English or American English. American English or UK English. For length. Okay, because we have 7 fundamental quantities. So they also have units we use to measure them. Kilogram, seconds, ampere, Kelvin, mole, candela, and meter. These are called what? Fundamental units. From here, we are going to derive other units. We take from here to get the other units. So other ones are called derived units. Okay? So let's just give few examples of derived unit because they are coming from the base unit. Okay? For instance, Newton. Newton is for force. Okay? We use this to measure force. What is force? Force is ma. That is mass times acceleration. So what is mass? Mass is what? Is a fundamental quantity. This is used for mass, kilogram. The short for kilogram is kg. Multiplied by acceleration. What is acceleration? Acceleration is velocity over time. You may not know this one, don't worry, okay? What is this? Is meter per seconds. That is for velocity, while time is seconds. Time is fundamental. You have seen that it's fundamental unit. Okay, let me not do this. Before we come back here, also know that what velocity is a derived unit. Because velocity is what? Displacement over time. What is the unit for displacement? Is meter. Unit for this is seconds. So we say what? Velocity is actually meter per seconds. Okay? Acceleration too is also derived. Why do we say it's derived? Because it's coming from velocity. Acceleration is coming from velocity over time. As you can see, this velocity is also derived from displacement over time. Okay? So, this one and this one came together to form velocity. Okay? And the velocity came with time to form acceleration. So, to get the unit for this, we say this velocity is meter per seconds, and this is seconds. If you work this out now, you're going to have meter per second square. So let's go back to force. As you can now see, this force is made up of 1, 2. This is a base quantity, but this one is derived. To get the unit of this now is kg, that is kilogram. While the unit of this, as you have seen, is meter per second square. Meter per second square. If you multiply these two now, you're going to have what? Kg meter per second square. It is this one we are calling Newton. Newton is the name of a person who worked very hard on this To recognize him, we change this one to Newton. So this Newton is actually representing kg meter per second squared. So it is a derived what? A derived unit. This Newton is a derived unit because force is a derived quantity. Okay? Also, energy. Energy is also derived. Okay? Energy is measured in joule. That is J. But what is joule? Joule is actually this meter square per second square. Okay? So, as you can see, this is coming from where? Mass. This is coming from where? Distance. This is coming from where? Time. This came together to form energy. So we say energy is derived from here. Okay, so energy is a derived quantity. The same thing with volt. Volt is watt over ampere. You may not know all this, don't worry. But what you should appreciate here is that all these are coming from somewhere. They are coming from somewhere. And where they are coming from are the base quantity. That is the base unit now. Unit for fundamental quantity. So I just want to prove to you that volt is also a derived unit because coming from the base unit. Okay? So volt is watt over ampere. Okay? But what is watt? Watt is actually joule over seconds. Okay? But what is joule? Joule is Newton multiplied by meter. Okay? So what is Newton? You see, we are trying to trace it back to the base unit. Okay? Newton's what? Is kg multiplied by meter over this. Okay? So, if you substitute all this now, you are going to get volt to be kg dot meter square over this raised to power 3. Now, this is mass, a base unit. Length, base unit. Seconds, base unit. All came together to form volt. So we say what? This is what? A derived unit. Hope you understand what we are trying to prove. Derived and base. So, never forget that we have 7 base units or 7 base quantities or fundamental quantity or fundamental units. All these in physics always go and form other units or other quantities. Okay? For this fundamental, a little light on it again. Remember that this one, let me put it here. This one is kg. This one is seconds. This one is ampere, is A. That is the unit abbreviation. This is the abbreviation. The abbreviation. Y Kelvin is K. This is mole. This is CD. CD. Why this is M. Okay? Put that at the back of your mind. Okay? That is the abbreviation for kilogram, seconds, ampere, Kelvin, mole, candela, and meter. Okay? Now, let's look at this exercise. It says, show how the unit of density was derived. How the unit of density was derived. Okay? What is density, by the way? Density is actually equals to mass over volume. Okay? And you agree with me that mass is a fundamental quantity, but volume is not a fundamental quantity. So what is volume? Volume is actually length multiplied by length multiplied by length, because length is a fundamental quantity. So as far as these are concerned, these are fundamental quantities. Mass, length. They are fundamental quantities. Okay, we stop here. We can't go beyond here because this is where everybody is coming from. Okay, now that we are here, we need to now get the unit of each of these. You agree with me that the unit of these, that is the unit of density now, is equal to, what is the unit of mass? Is kg. What is the unit of length? Is meter. Multiply by meter, multiply by meter. How many meters do we have? We have 3 meters now. That is 1, 2, 3. That is m raised to power 3, which you can express as kg per meter cube, or you say kg meter raised to power minus 3. Okay? This is how the unit of density is derived. We derive this from the fundamental unit. Hope you understand this. Let's look at this. It says, show how the unit of force was derived. Unit of force, okay? The first thing you must do is to look at force. What is force? Force is what? Mass times acceleration. Okay? So what is mass? Mass is a fundamental unit, but acceleration is not. That is fundamental quantity. I mean, this is fundamental quantity, but acceleration is not. So we're going to say mass multiplied by acceleration. What is acceleration? Acceleration is actually velocity over time. Okay? Say velocity over time. What is velocity? Is velocity derived or fundamental? Velocity is derived, but time is not derived. Time is fundamental. So we are true with this time. We are not true with this. What is this? This is length over time. That is, this guy that is taking the place of velocity now is length over time. Remember, velocity and speed, when it comes to unit, we use length over time. Okay? Now, what we have here now is mass, which is fundamental. Length is fundamental. So it's not length over this will give us time multiplied by time. If you do the math, length over time is length over times time. So, on this numerator now, you agree with me, this is kg, this is meter, this is seconds, this is seconds. So, to get the unit of force now, we put kg, we put meter, this is square. It means kg meter per second square, which you can rewrite as kg meter raised to power minus 2. So this is the derived unit of force, kg meter per second square. Let's look at this. It says, which of the following is the derived unit of pressure? Let's see. First of all, what is pressure? Pressure is simply force over area. Okay? And you agree with me, both this and this are both derived. What is force? Force is mass times acceleration. Mass is a fundamental unit. Acceleration is velocity over time. Okay? What is velocity? Velocity is length over time as per moving it to basic quantity. That is fundamental quantity. That's why I'm bringing length here. I should have said displacement over time. Okay? So, what is the unit of, let's go to unit now. Unit of mass is kg. Unit of length is meter. Time is seconds, second. It means this will give us kg meter per second square. Have we done this? Let's now go for area. What is area? Area is length times length. Because if you look at this, we say length times breadth. But this distance here to here, this also distance. The same thing with, say, want to get for this. The same thing. This is length. This is length. So it's length. So when you go to unit aspect of it, this is meter multiplied by meter, which is meter square. Therefore, it means now we have this for this first, we have this for this area. So therefore, we're going to substitute. Say pressure as per unit, we put this kg meter per second square all over meter square. So now we can say this to express it, say times this all over this divided by this over 1. Then if you want to express it further, kg times this times 1 over this. Here 1, here we have m. It means we have kg per, that is over, meter, this, which you can express as kg. Because of this over, you put -1 here. Because of this over again, you put this minus again, raised to power 2. So this is actually the derived unit. Okay, meter raised to power 1, s raised to power -2. So as you can see, this is the answer B. Okay? So that is the derived unit of what? Of pressure. Okay? Let's look at it. It says, which of the following unit is equivalent to the watt? What is watt? Watt is the unit of power. Okay? Watt is the unit of power. But what is power? Power is simply work over time. You can also say power is equals to force multiplied by velocity. All this, if you are studying physics, you may not know. Don't worry yourself. You can always use this to reverse, okay? We are assuming you understand the meaning of power, the meaning of watt, okay? Now, what is force again? Force is MA. We have been treating force. Don't need to waste our time. We have agreed several times that this is simply M L T raised to power 2. We have done that. That is mass times length over time raised to power 2. What about velocity? You agree with me that velocity is actually length over time. So now, because we have said power is F multiplied by V, we can say as well that this is ml over t squared, that is for force, therefore velocity is this over t. Okay? Now, you agree with me, if we go further, what is the unit of m is kg? That is mass. This is meter. This is seconds raised to power 2. This is meter. This is seconds. It means, therefore, if you multiply all this, you're going to have kg m squared over s raised to power 3, which you can write as this. Because of this over, you put -3. This is simply for what? For power. Let's see if any of them is correct. B again happens to be the correct answer. Okay? Hope you understand this. Thank you for viewing.